Hi friends, Dr. Voroli is here. Let us see today the other primary pressure measurement sensors. The one is mechanical diaphragms. Here the construction of mechanical diaphragm is shown in the figure. Mechanical diaphragm is a membrane which will be stretched between two firm support. It can be with corrugation for larger flexibility and displacement. Figure 2 shows the corrugated diaphragms. The diaphragms are made up with PVC material or they can be made up of metallic alloys. Depending on the application, we can choose the diaphragms from the plastic diaphragm category or the metallic diaphragm category. The operation of the diaphragm is shown in the figure. Whenever here you will see the diaphragm is stretched between two rigid surfaces. When the pressure is applied to the diaphragm, it gets deflected and the deflection is proportional to the pressure applied. The deflection of the diaphragm is maximum at the center. Typically in a sensor using the diaphragm as a primary sensor, as shown in the figure here. See, this is a diaphragm. There is a fluid port available from which the fluid enters in the chamber. The mechanical connection is provided for that purpose. This fluid exerts the pressure on the diaphragm. On the other side of the diaphragm, there is a sensor which measures the displacement of the diaphragm. The displacement can be measured by displacement sensor or it can be by a strain gauge sensor or it can be by a semiconductor chip sensor. Different principles are employed to measure the displacement of the diaphragm. Let us suppose that we have connected a chip sensor here. Now when the fluid pressure is applied, there is a deformation and deflection of the diaphragm. The deflection is proportional to the applied pressure. Therefore, the chip sensor which provides the output proportional to the deflection. The electrical output is available at the output of the sensor. If the detection element connected to the diaphragm is a strain gauge, then output of a sensor is in the form of change in resistance. Further, you can connect a signal conditioning circuit, mostly in the form of Wheatstone bridge, to convert this change in resistance to the proportional voltage. Here, the third figure shows how the practical diaphragm sensors are looking like. Here, you will see the corrugated diaphragm and which is a metallic diaphragm, mostly for high temperature application. The metallic diaphragms are used. The stainless steel diaphragms are quite common for corrosive applications. A practical construction of a capacitive type of sensor is shown here. This is just for the sake of additional knowledge. This is optional from your syllabus point of view. So here this diagram indicates a corrugated diaphragm. The mechanical housing is provided and the fluid connection pipe is also shown, which allow the fluid connection to be done to the sensor, and the fluid is allowed to exert the pressure on the diaphragm. When the pressure of the media is applied to the diaphragm, it deflects. This deflection can be measured directly by the element installed on the diaphragm, or in this particular case, there is a non-compressible transmission fluid capillary is provided, and this pressure will be transformed to the another location where the secondary diaphragm can be equipped with the measurement sensor like strain gauge or capacitive sensor. So this can be a remote seal type of diaphragm sensor. Whenever the electronic for measurement of the displacement is not advised to be installed on the diaphragm, in that case the remote seal capillary type of extensions can be used. Whereas where the electronics is possible to be installed on the sensor diaphragm, then in that case the sensing element will be directly installed on the diaphragm itself. Okay. Here a proprietary capacitive type of load cell is shown. This area is the diaphragm, isolating diaphragm. From this diaphragm, the pressure is applied to the sensing diaphragm inside. This is the sensing diaphragm, the straight line shown here. These two plates, one plate is fixed and the diaphragm is a movable plate. When the pressure is applied to the isolating diaphragm, this pressure will be transferred to internal diaphragm and that diaphragm will be deflected. When this diaphragm deflects, there is a change in distance between fixed plate and the diaphragm, and therefore there is a change in capacitance between the fixed plate and the diaphragm. This capacitance change can be proportional to the applied pressure. Normally, the isolating diaphragm and the measuring diaphragm connection capillaries are filled with non-compressible dielectric oil. For the sake of simplicity, this part can be skipped from your syllabus point of view. The operation of capacitive transducer can be explained by the relation of capacitance of a parallel plate capacitor. We know the capacitance of parallel plate capacitor is given by epsilon A by D. Epsilon is the permittivity, A is the area of the plate, and D is the distance of separation. So whenever pressure is applied to the measuring diaphragm, the distance between the fixed plate and the movable diaphragm changes, and therefore the capacitance changes, which is in turn proportional to the applied pressure. A typical construction of a diaphragm type of sensor is shown in this figure. This is for additional information. Some sensors have this type of construction also. You will see there are two fixed plate of the capacitors. Here, these two plates and these are the fixed plates. In between the fixed plate, there is a diaphragm, metallic diaphragm plate stretched between the two rigid supports. And this diaphragm is connected to an external pressure port via pressure bellow. Bellow is one of the mechanical device. Whenever we apply the pressure, it will be elongated. So in this sensor, when the pressure is applied to the pressure port, bellow will be expand and it will exert the pressure on the measuring diaphragm. When the pressure exerts is on the measuring diaphragm, the distance between the fixed plate and the diaphragm will change, and as per the formula of capacitance between the two parallel plates, we will see that due to change in distance there is a change in capacitance. This change in capacitance can be further converted to proportional electrical signal by signal conditioning circuit. The another type of primary sensor is a mechanical capsule. The construction of mechanical capsule is shown here. The capsule is formed by welding two flexible diaphragm type of disc with corrugation here shown with a pressure port, so that from this port the pressure fluid can go inside, and when pressure is applied the capsule will be expand and the movable end of the capsule will be deflected. Here double capsule is shown in the figure. So whenever pressure is applied, due to pressure the capsule will be bulged and therefore the moving end will displaced. This displacement can be measured with the displacement sensor. So therefore the capsule acts as a primary sensor. One of the application of this capsule is shown in this figure. That is one of the pressure gauge. See here in the first figure, the pressure is applied via pressure port to the capsule. When pressure is increased, this capsule will expand, and due to that the rod connected to the capsule is moving out when the pressure is increased. When this rod is moving out, this mechanical gearing arrangement drives the gear train and moves the pointer on the scale. The wiper position on the scale indicates the pressure that is applied. Here in another figure, a differential pressure gauge is shown. In the first figure, the pressure is measured with absolute reference, whereas in a second figure, the differential pressure measurement is done. The reference pressure is allowed to go inside the capsule via pressure port 2. Normally, the reference pressure in differential pressure gauge is atmospheric pressure. So, therefore, this port is open to the atmosphere, and the measurement port is connected to the external pressure fluid. It can be gas also. Whenever the pressure increases, the capsule elongates, and due to that, this moving end push the rod up. When this rod goes up, the gearing arrangement moves the pointer on the scale. The applied pressure is converted to proportional deflection on the scale. Differential pressure gauge can be used for measurement of pressure with respect to atmospheric pressure, whereas absolute pressure transducer or absolute pressure gauges can be used to measure the pressure with absolute zero pressure, and this is one of the application of the capsule type of pressure transducer. The next mechanical device that can be used as a primary sensor for pressure measurement is a bellow. Bellows are basically a flexible corrugated tubes as shown in the figure. Here figure 2 indicates a rubber bellow made up from silicon rubber, whereas in the third figure a bellow using metal is shown, mostly using the corrosive fluid pressure measurement applications. The silicon steel bellows are used. The operation is very simple. Here this tube is sealed at one end and other end have a connection for pressure fluid. The sealed end can freely move under the application of the pressure. When the pressure is applied to the pressure port, the bellow will be stretched and the sealed end is moving. The applied pressure decides the displacement of the moving end. This displacement can be further measured by using any displacement sensor. One of the application we have seen in the capacitive sensor. Another primary transducer used for measurement of pressure is a Bourdon tube. Bourdon tube is a tube of C-shaped English character. So as shown in the figure, this is a tube. Whenever we apply the pressure to this tube, due to pressure, the freely moving end will move and the displacement of this end will decide how much is the pressure applied to the pressure port. The figure 2 indicate the twisted Bourdon tube. In this case, whenever pressure is applied to the tube is untwisted and the remote end of the tube is getting untwisted and the displacement of this end can be measured by using displacement sensor. The third figure shows a helical Bourdon tube. Whenever pressure is applied to this tube, the helical tube will be expand and it will be uncoiled. So the remote end will be uncoiled and it is getting displaced due to application of pressure, and this displacement can be used for measuring the applied pressure. A typical pressure gauge using Bourdon tube is shown here. See here the internal structure of a pressure gauge. It consists of a Bourdon tube and some gearing arrangement. This gearing arrangement is connected to freely moving end of the Bourdon tube. So whenever pressure is applied to this Bourdon tube freely moving end gets stretched and it is moving due to the applied pressure. When it is moving, this mechanical link rotates the pinion gear and therefore the pointer attached to this pinion gear will record the pressure on the calibrated dial. This way Bourdon tube can be used for measurement of pressure. The electrical type of pressure sensors we will see in the next lecture. Till then, bye bye friends.